afternoon and welcome back to Elementary Algebra. I am your instructor, Amy Fuchsteiner. I'm wearing my favorite green sweater. I don't know why I like the daisies on it. I just do. It's just one of those things for springtime, I think. We're trying to have like an issue with the light, but I'm not sure what's going on. So if I'm going in and out of darkness, you know why. It's my lighting and the bright sunshine from the afternoon. So all right, so we introduced Chapter 7 and rational expressions last section. So this section, we're going to start working with them. We're going to be multiplying and dividing rational expressions. So when you do that, when you multiply rational expressions, basically it's just like when you multiply fractions. You want to multiply the numerator, and then you want to multiply the denominator. Right? The great part about multiplying rational expressions is that we want to factor first. If we factor out the numerators and the denominators first, then we eliminate a whole bunch of work because once you multiply them together, they just get harder to factor. This is a lesson that we hope you learned when you were doing numbers. So, for example, when you had fractions like 63 over 10 times 40 over 27. Nobody wants to multiply 63 times 40 and then 10 times 27 and try to factor those large numbers. It is much more efficient if you realize that 40 is 4 times 10, that 63 is 7 times 9, and that 27 is 3 times 9. Then you can start factoring and canceling the 10 with the 10, the 9 with the 9. And you can get to an answer with much smaller numbers. When we factor our rational expressions, we're going to do the same thing. We're just going to do it with polynomials. Yay! Okay, so what does that look like? We'll start with some not so tough ones. All right, we'll start off simple, and I say that as a relative term in terms of where we're going. All right, so here we have 2x over 3 times 9 over 7y squared. Basically, what we want to do is we want to look at this and see, does anything cancel, right? So the 2x over 3 times the 9 over 7y squared. Hopefully, you recognize 9 is 3 times 3. I'm not saying you have to write that part out, but hopefully you do recognize that 9 is 3 times 3. And if I wrote that out, I could cancel those 3's, right? 3 goes into 3 once, 3 goes into 3 once, leaving me with 2x times 3 over 1 times 7y squared, or 6x over 7y squared. And that's it. That's what happens, right? We cancel what we can, and then we multiply across the numerator, and we multiply across the denominator. Now, with numbers, we often do a lot of factoring in our head. What number goes into both 3 and into 9? Okay, it's 3. When you're actually factoring polynomials, you can't, that mental step often needs to be written out. Okay, so let's take a look at problem number 2 here. Problem number 2, we have 6x times x plus 7 over x minus 4. This guy, that x plus 7 is one polynomial altogether. That x minus 4 is one polynomial altogether. I can't cancel anything here. That's all in a numerator and all in a denominator. In fact, I don't have any factors that cancel. There's nothing in the numerator that is exactly like what's in the denominator. So there's not going to be any canceling here. Sometimes that happens. And when that happens, you just go ahead and multiply. This is going to be 6 times that x plus 7 over x times the x minus 4. This is the polynomial in factored form. That is an absolutely fine answer unless the instructions for the problem say to go ahead and multiply it out. If they ask you to multiply it out, then you want to distribute. So we have 6x plus 42 over x squared minus 4x. Both of these are equivalent answers. It just depends upon the format requested for the answer, right? My preference is this one because I can go to this step quickly. So I usually prefer the factored form, but both are accurate and both are good. All right, here I have in number 3, 12a squared b cubed times c to the 4th over 3a cubed c times 20a squared bc. Oh, Lord. Okay, I'm going to do a little organizing. Normally, I would just do this in my head, but I'm going to write it down for you. So here in my numerator, I'd have a 12a squared b cubed times c to the 4th over, I'm going to do a 3 times a 20. I'm just moving stuff around. And this would be a cubed times a squared times b times c times c. Okay. All right, so before I write anything, I'm going to start canceling. 12 and 3 is a 4. The a squared cancels with the a squared. The b will make this a b squared. The c to the 4th will be c squared. Now, I do look at this and I do see that I can do a 4 once, and that's a 5. So I am left with 1 b squared c squared over 5. That's a 1 times 5 times a cubed. So that's a b squared c squared over 5a cubed. Gorgeous. Done good. Okay. Done and done. All right. Now, number 4, here I have a binomial, so I can pull something out of that. I'm going to factor first. When they start getting really messy like this, I'm going to look for factors first. So in my numerator here, I can pull an x out, x plus 3. In my denominator, 3x, I can pull out a 3. X cubed, x squared, I can pull out an x squared. And then I'm left with x plus 2 times, nope, this would be an x plus 2 over x plus 3. Do you see what's going to happen? Do you see anything in that numerator that can cancel with anything in that denominator? I see a couple of them. This x plus 3 and this x plus 3 are exactly the same. So I can cancel them out. They will be a 1. This x plus 2 cancels with this x plus 2. Both would be a 1. That leaves me with an x over 3x squared. Oh, I missed something. Do you see what we missed? Now, I can cancel this x with this x squared, leaving it just an x to the 1st. So now that's going to be a 1, because x over x is 1. So I'm going to have 1 over 3x. That's it. Yeah. Okay, good. Let's keep on moving. We're still multiplying, I believe. Oh, yeah. Yeah, because I can't leave it. It's got to get harder. All right. So here I've got a y squared plus 5y over y squared minus 25. A y squared minus 4y minus 5 over y squared minus 1. Okay. Let's look to squared so I can maybe factor something out. Y squared plus 5y. Pull a y out. Y plus 5. In my denominator, I've got y squared minus 25. 25 is a perfect square. Y is a perfect square. This is a difference difference of two squares. So I've got a y and a y. A 5 times 5 is 25. This is a difference. So one is positive, one is negative. That takes care of all of this guy. Times, and I need another one, y squared minus 4y minus 5. This is a trinomial, 3 of them. So we're going to have a y and a y. So what two numbers multiply to give you a negative 5, but when you add them, you get a negative 4. So negative 5 would be a negative 5 and 1. Yeah, that's it right there. Minus 5, 1. And then in my denominator, I have a y squared minus 1. Y squared is a perfect square. 1 is a perfect square. This is a difference of squares. 1 and 1. 1 is positive, 1 is negative. Once they are all factored out, then I can see what might cancel. All right, here I have a y plus 5. Looky there, y plus 5 there. Those will cancel. That's a 1, right? 1 over 1. Here I have a y minus 5. Looky there, got a y minus 5 there. That cancels with a 1 as well. Then I've got a y plus 1. Looky here, I've got another y plus 1. That cancels with a 1. So now in my numerator, I have a y times 1 times 1 times 1. 1 times 1 times 1 times y minus 1. So that's going to be a y over y minus 1. Resist canceling the y's. You can't cancel the y's. This y has a minus 1 tagged onto it. This y does not. They are not exactly the same. You cannot cancel them. Okay? You cannot do it. I know you really want to, but you cannot. If you had this problem, let's say you had 2 over 2 minus 1, would you cancel the 2's? You wouldn't. You can't cancel anything until you do the subtraction. It's the same thing here. Because all that's left in that denominator is subtraction, I can't cancel the top until I do the subtraction. So don't do it. Don't do it. Do not. All right. I feel like my glasses are really slippy, but okay. Hopefully you won't. All right, 6, I have an r squared minus r minus 56. That is a trinomial. It should factor. So what are the factors of 56 that add to be a negative 1? What are the factors of a negative 56 that add to be a negative 1? So negative 56. What's 56? So it's 2 and 28. So negative 28, and I know it's not 1 and 56, by the way. So 2 and 28, would 4 work? Negative 14 and 4, also not it. Negative 8 and 7 times 6 is 50. I don't know why I didn't think of that. All right, so we've got an r and an r, and then it would have to be the 7 and the 8. The 7 is positive, the 8 is negative. Okay. Then in my denominator to factor that, I'm going to take a 3 out, and that's going to leave me with r plus 4. All right. My second one, I've got an r squared and a 16. It is 2 terms, and it is r squared, so this could be the difference of squares if 16 is a perfect square. It is. It's 4. So this means we'll have an r and an r, a 4 and a 4. And in order to have 0 there in the middle, one of these needs to be positive, one of those needs to be negative. All right? So now I have factored that one. I just have r squared minus 12r plus 32. So what are the factors of 32 that would add to be a negative 12? So it's not going to be 1 and 32. I know that one is not. Okay, so what about a 2 goes with 16? If I add those, I get 18. That's not going to work. 4 and 8, and if I add those, I do get 12, but I need a negative 12. So negative and negative Negative times a negative will get me a positive, but it adds. All right. So this is going to be an R and an R. Minus 4, minus 8. Okay. Now that everything is factored, now we want to see what cancels. Here we have an R plus 7. There are no other R plus 7s. So that's not going to cancel. I have an R minus 8. There is another R minus 8. Cancel. I have an R plus 4. I'm already ahead of myself. There's an R plus 4. I have an R minus 4 with another R minus 4. So I am left with an R plus 7 over 3. Can I cancel anything more there? No. That R plus 7 hangs together until I can add. I won't be able to cancel anything more until I know what R is. And since I don't know what R is, this is it, and I am done. Okay. Great. Second goal, we're only on goal 2. Okay, so we want to multiply the rational expression by a polynomial. Oh, okay. So basically all this is saying is if you have 26x times 2 over 13x, we want you to consider thinking of this as 26 over 1. Just like we did when we actually worked with fractions. Just turn that particular polynomial into a rational expression by putting it over 1. Then we can cancel 2, 1, 1, 1, and we're left with 4. 2 times 2, which is 4. Right? Similarly, for number 8, I'm going to rewrite this as x plus 5 over 1 times, this is going to be an 8. And then I need the multiples. Oh, what multiplies to give me a negative 66, but adds to give me a negative 6. Oy. Okay, so this should factor. It starts with a 1, so I'm okay doing my mental math. 66 is going to be 1 and 66. That's not going to, negative 66 and 1. That's not going to add to be the negative 6. That's in the middle there. What about 2? 2 and negative 33 also does not add to negative 6. 4 won't work. 5, nope. 6. 6 times a negative 11. That does not add to be a negative 6. Yeah. Okay, so this guy's not factorable. Because that's not going to add, that's going to add to be a positive 5. Maybe I meant to do a negative 5 there, but even then, seems to be prime. So that's not going to factor any further. And that's okay. Sometimes that happens. So this would simply be an 8x plus 5 over x squared minus 6x minus 66. This is it. This is as far as it goes. This one didn't factor, so I can't put factors down here. That just stays, right? So this is it. This is as far as she goes. It's as much as she wrote. Okay. Not perfect, but it happens. Okay, let's look at goal number 3. I feel like I'm missing a page. There it is. All right, goal number 3 is dividing. We're going to divide some rational expressions. Again, we're going to assume that none of the denominators are 0. And what we're going to do here is we're going to use the information from fractions. That is that division is multiplication by the reciprocal. Right? We're using the definition of division as multiplication by the reciprocal. I am going to actually, I prefer to do the reciprocal part first. So This is going to be a negative 9x over 7y times, and then these get flipped, 35y squared over 18x. Once you have flipped it, then you want to factor. These are monomials, so we won't be factoring them. Negative 9 and 18 is 2. 7 is 1. 35 is 5. Y squared and y, this y will cancel, giving us y to the first. And the x's will indeed cancel as they are both x to the first. In the numerator, this leaves me with a 5 and a y. In the denominator, I am left with only a 2. So this would be 5y over 2. Okay. So problem number 10, we're going to keep 4x minus 28 over 3x squared. Change your division to multiplication and then flip. So 12 and x squared minus 49. I like to do the keep, change, flip part first. Then I'll go back in and factor. So this will be 4. I can factor out of 4, x minus 7 over 3x squared times 12. And then x squared minus 49. That's a squared and a difference, 49. So this would be an x. 7 times 7 is 49. So this will be an x plus 7, x minus 7. Once I have it factored, then you go back into cancel. The 7s cancels. The 4 won't cancel. The 12 will cancel. So we're left with 16 over x squared, x plus 7. Right? Because that x squared didn't cancel with anything. There we go. Okay. Problem number 11, same idea. This is a division problem, but we're going to use the idea or the concept from numbers that you keep the first. D squared minus 4 over d squared plus 4 times d plus 3. You change the division to multiplication, and then you flip or use the reciprocal, d squared plus 2d minus 3 over d squared minus d. Again, I like to write out the keep, change, flip part first. Now I'll go back and factor. D squared minus 4. D is squared, 4 is 2 squared. This is the difference of 2 squares. Then in the denominator, I have a d squared plus 4 times d plus 3. This is a 1. It is a d squared and a trinomial. So this should or could factor into two numbers that multiply to give me 3, but add to give me 4. Yep. 1 times 3 is 3. 1 plus 3 is 4. That works. The second, got d squared plus 2d minus d. I got a trinomial again. It should factor. What two numbers multiply to give you a negative 3? That's only going to be a 1 and a 3. But how can I arrange the signs so that when they add, I get a negative 2? It's a plus, a negative 1, and a plus. Now in the denominator, I have a d squared minus d. I don't have a trinomial. This is not a perfect square. So can I factor anything out of the two of them? Yep, I can take a d, and then I'm left with d minus 1. All right, once it's all factored, then I check to see what can cancel. Here I have a d plus 2. There are no d plus 2s in the denominator, so that will stay. Here I have a d minus 2. There are no d minus 2s in the denominator. Stays. Here I have a d minus 1. That will cancel with the d minus 1 in the denominator. And I have a d plus 3. That will cancel with the d plus 3 in the denominator there. I am left with d plus 2, d minus 2 over d times d plus 1. This is the answer in factored form. Perfectly fine. You could also multiply that out if you wanted. This is the difference of two squares. This would be d squared minus 4 over d squared plus d. This is also an acceptable answer. I tend not to go that step because if I make an error in my multiplication, all this is for naught, right? If you make an error going from this step to this step, you're going to type in the wrong answer. So I start here. And sometimes I leave it that way. Here you go. All right, problem number 12, keep. So I got a 9w squared plus 3w minus 2 over 3w plus 2. Division changes to multiplication, and then I got to flip. Oh. So this would be over a 1. So when I flip it, it's going to be 1 over 1 minus 3w squared. Okay, great. Now, this guy, I'm going to have to maybe go off a little bit, right? So I'm going to need to take my 9w, make myself a little room, 9w squared plus 3w minus 2. This is not leading with a 1. So I'm going to do factoring by grouping on this guy. What are the factors of a negative 18 that add to be 3? What are the factors of a negative 18? So negative 18 would be an 18 and a 1, a 9 and a negative 2, a 6 and an, okay, so it's the 6 and 3. That's the one that works. The 6 and negative 3. So this would be a 9w squared plus 6w minus 3w minus 2. Okay, that's good. Now from my first 2, I can pull out a 3w. That's going to leave me 3w plus 2. And here I can pull out a minus 1. And that's going to leave me 3w plus 2. So this is going to factor into 3w plus 2 times 3w minus 1. Okay. All right. So I got to squish a little bit, but I'm going to get 3w plus 2 over 3w minus 1 over 3w plus 2 times 1 over 1 minus 3w squared. Okay, so this 3w plus 2 will indeed cancel with this 3w plus 2. This is 3w minus 1. That's 1 minus 3w. Oh, 3w squared. The squared here is ruining it for me. Squared is, okay. So this is going to be just a 3w minus 1 over 1 minus 3w squared. Because this is squared and this guy isn't, I can't cancel. I can't cancel when one is squared and one is not. So this is it. That's as much as she wrote. Can't do anything more. I mean, maybe you see that this appears to be an opposite, that I could factor out a negative 1. And I could put a negative in front of all of that to factor out a negative 1. But I wouldn't need to because I can't factor any further. So I could just leave it there. That would be okay too. All right. So division is not difficult. You just need to remember to use that keep, change, flip. And you should be just fine. Right? The fourth and last goal is converting some units of measure. And in order to do that, they're asking you to use some conversion units or some unit conversion factors. The idea here with a unit conversion factor is that you can take any conversion, 12 inches is 1 foot, and you can rewrite this as a fraction. That as a fraction, you could write this as 12 inches over 1 foot, or it could be 1 foot over 12 inches. That because 1 foot and 12 inches are two different ways of saying the same thing, you essentially are just using one. 1 foot is to 12 inches, or 1 foot over 12 inches is the same thing as 12 inches is to 1 foot. So 3 feet is to 1 yard, the same way that 1 yard is to 3 feet. 60 minutes is to 1 hour, 60 seconds is to 1 minute. There are some very overused, I guess you could say, conversions that we assume that you know. If you come across one of those and you don't know it, please don't hesitate to ask. But we do assume that you know that there are 12 inches in 1 foot, 3 feet in 1 yard, 60 minutes is 1 hour, 60 seconds is 1 minute. And if there are other conversions, we will try to remember to give them to you, to feed them to you. But just be careful about Googling things. I know that you have Google on your phone and you can ask Google how many feet are in a mile, and that's fine. But if you ask Google how many feet are in 3 miles or 2.5 miles or something like that, you may get a slightly different conversion for some of the conversion facts. It has to do with rounding and precision. May not happen for feet in a mile, but it might happen for kilometers to mile. The conversion fact that we ask you to use may be rounded or slightly different in that respect from the conversion fact that Google uses. And that can cause you to get wrong answers if you're not using the process and instead trusting the computer. Okay? All right. So how are we going to use it? Here's one where we have 630 square feet to square yards, and we want to use the unit conversion factors. We start by writing 630 square feet, which is the feet squared. So we start by writing that down. We know that there are 3 feet in 1 yard. Now, since we want to convert away from feet and to yards, we want to cancel the feet and leave the yards. That tells me that when I use my conversion fact, I want to make sure my feet are in the denominator and the yards are in the numerator. That also tells me the placement of my numbers. I know 1 yard is 3 feet. The problem that remains here is that these feet are squared and these are not. So I will cancel the feet squared with the feet, but it's only going to cancel one of them. So I need to either square it or to write this down a second time. Now both of these feet will cancel with the feet squared, and I am left with 630 yards squared over 9, or 70 yards squared. Okay, let's try a second one. Patri and Jay purchased a 120 square meter apartment in Portugal. As an American, Jay does not have a reference for square meters and needs to convert it to square feet. He would like to know how the size of this particular flat or apartment compares to his 1,800 square foot apartment in Chicago. Like, he just sort of wants to get a visual. If we know that there are 3.281 feet in 1 meter, use the unit conversion method to help Jay determine the size of this apartment. So we're going to start with the 120 square meter apartment. And we want to convert it using 3.281 feet in 1 meter. Since the meters are what we're trying to get away from here, we're going to put meters on the bottom and feet in the numerator. There are 3.281 feet in 1 meter. The problem is that the apartment is in meters squared and the conversion we know is singular. So I am going to go ahead and multiply that again by 3.281 feet in 1 meter. Now I have done a square of the conversion. So the meters will cancel with the meters squared. And I'm left with 120 times 3.281 squared over 1 feet squared. And this, and this is 120 times 3.281 squared is 1291.8. Okay, so 1,291.8 square feet. How does this compare to his 1,800 square foot home in Chicago? It's smaller, right? So in comparison, it's smaller than Chicago, probably by about one room. Just as a quick FYI, this problem comes from an actual conversation I had with some friends of mine, Patri and Jay, we'll call them. Patri actually moved to the States and was not able to convert. Like, she did not understand the size of a 2,400 square foot home. Like, that meant nothing to her. And so eventually I gave her a workable conversion. I said, just divide by 10. So if you have a 2,400 square foot home, that converts to about, while loose conversion would be about a 240 square meter home. So if you ever watch House Hunters International, now you'll know. When they say it's a 90 square meter apartment, you know that's about 900 square feet. So small. Okay? All right. Here we go. Another conversion. Monarch butterfly migrates from Mexico to the northern U.S., traveling as fast as 4 miles in an hour. Using unit conversions for time and knowing there are 5,280 feet in a single mile, determine how fast this butterfly flies in feet per minute. Feet per minute. Okay. So traveling as fast as 4 miles per hour. That's 4 miles per hour. That's 4 miles in 1 hour. So there's actually two conversions going on here. I have to convert the miles to feet. Now, miles to feet, the miles would go cancel, so they would need to go into the denominator. Sorry. We have glitched. All right. Here we are. Okay, so miles and feet. All right, so 5,280 feet in 1 mile. That will cancel out our miles. Now we also need to convert hours to minutes. So to convert the hours to minutes, if I want the hours to cancel, if I want hours to go away, to cancel them, I need to put them in the numerator and then convert them to minutes. We know that 1 hour is 60 minutes. That will cancel the hours. Oh, how did I get 81 there? There we go, 5,280 feet. All right, now, that leaves my units in feet and minutes, and that's what I was supposed to get, right? Feet per minute. All right, so that's good. So now I'm going to have 4 times 5,280 times 1 feet over 60 minutes. So now I'm going to do that math. 4 times 5,280 divided by 60. So that's 300 feet. Yeah, there we go. That's 352 feet per minute. Those little monarch butterflies can fly fast. 352 feet per minute. How much is that? 352 feet per minute. That's more than a football field, right? Football field is 100 yards. That's 300 feet. Yeah, I think so. I think that's more than a football field in a minute. All right, great. All right, that rounds up the fourth of the 4 goals for this section. And so we have now multiplied rational expressions with the polynomials. We've divided them, and then we talked a little bit about converting units of measurement. So those were the 4 goals for section 7.2. If you have any other questions about 7.2 or any of the material we've covered so far, please don't hesitate to reach out to me or to Julia in the Math Center. They're all waiting to help you, and I'm pretty sure they're open until 9 o'clock every night, but Friday and Saturday. I think they're even open Sundays. Have to check their schedule. All right. Thank you all so very much, and we'll see you next time.